something we need to understand going forward, again, into the analysis. Again, this is just showing how the analysis of complex survey data is pretty common. When we think of complex survey analysis or complex data, we might think it's complex because it's hard. No, that's not the meaning at all. It's complex because of the complex survey design, not because it's complex to do. All right, so just reinforcing that for those of us who might be scared at, oh, geez, this is very complex work. No, no, no. It's not referring to the complexity of the data itself, or it's not referring that it's complex to do. It's just saying that the design approach, the methodology, was something that was not simple random. It involved stratification and clustering. And so we have to account for those in analysis. Now, NHANES is not the only data set that involves complex design. There are many others. And here I've listed some of them. And this is for those of us who might be interested in looking at other sources of data other than the NHANES. You have NYTS, YRBS, NATS, TUSCPS, and so on and so forth. Some of them are very interesting because some have a whole range of measures captured or some range of information captured. So for example, some are state-specific and nationally representative. So YRBS, for example, and the National Adult Tobacco Survey, they can yield both nationally representative estimates as well as state-specific estimates. The same thing applies to BRFSS. BRFSS can only yield state-specific estimates, but not nationally representative estimates. Then there are some that are longitudinal in nature, like TUSCPS. It's not every year of it, but in some years, there's a longitudinal component. So if you're interested in looking at things over time, let's say you're interested in looking at, incidence of smoking cessation among smokers at baseline, you can use that survey. PATH also is longitudinal in its scope. And then there are some that contain biomarkers. So for example, NHANES is the gold standard for surveys that have biomarkers. So biomarkers will mean, things collected from a blood or from urine or other, bodily samples that can allow us to know what's happening within the body, right? Maybe indicators of health or of disease. So NHANES is one survey that contains biomarkers, but it's not the only one, of course, that contains biomarkers. You also have PATH and all of us. Again, so while this session is about NHANES, it's not only about NHANES, it's to broaden our mindsets to the range of data sets we have around us that we could use, which are similar in design to NHANES. Now, it's not just in the US. There are also global data sets that have similar design and similar information. Demographic and health surveys also has a lot of information that could be useful to researchers, those doing HIV, and there are some biomarkers in that data surveillance system as well. KNHANES is special relative to this discussion because it is based in South Korea and it's developed exactly after NHANES. So if you want to compare, indicators across country, the design is almost identical. All right, so we always talk about the cycle of inference because it's very, very important whenever we're talking about survey design, especially design of complex surveys. The cycle of inference simply acknowledges that we have a population and that population gives us a sample. NHANES doesn't survey everybody in the US. In an NHANES cycle, you might have a few thousand people, right? But the goal is that we hopefully want to make inferences from that sample back to the overall population, right? That's why we spend so much money on NHANES, because we want to make inferences from a sample to the population. And for you to do that faithfully, it means that you must ensure that you do the analysis. Your job is not to go and collect the data. Your job is to ensure that when you're doing the analysis, you are doing it correctly, that you apply the weights correctly, and that you account for all aspects of the complex design. All right, so just to, again, provide some of the overview of what we just discussed, the NHANES samples are not simple random samples, right? They are not simple random samples. That's what we call, the opposite of simple is complex, right? So if it's not simple random, if the design is not simple random, then it's complex. So again, to demystify or remove any iota of fear that, oh, geez, it's complex survey, so it must be complex. No, we call it complex because it's not simple random. And so it uses a complex multi-stage probability sampling design to select participants representative of a civilian, non-institutionalized US population. Why is this expression important? Well, it's important because in enhanced methodology, we're going to households. We're not going to prisons. We're not going to elderly facilities. We're not going to military barracks or military installations. We're going to households. We're not going to schools. We're going to households. So that's why this term is important. It's the survey of the civilian, non-institutionalized. We're not going to any institutions where people live, but to households. Oversampling of certain population subgroups is also done to increase the reliability and precision of health status indicators for those subgroups. So we come back to the issue of oversampling, and that's why we discussed it earlier. And that's why you have to understand why we weight the data. Because when you oversample, it means that some groups have higher probability of selection than others. And so to make everything even again, to make everything balanced, that is why we need weight. All right, that sets the stage for what we're talking about. And again, these three variables, we need to account for them: the weight variable, the PSU variable, and the stratum variable. In most surveys that you only have one weight variable. In most surveys you're going to work with, you only have one single weight variable. And then hence is a bit more complicated. You're going to have many, many weight variables. Remember, we said that NHANES uses three modes of data collection: self-reports, laboratory, and exams. Well, of these three, you can imagine, where will you imagine that you will see most participants? Imagine that you are the NHANES director and you have a fixed budget and you have, let's say, 10,000 people who participate in some of the self-reports, but you don't have money for labs for all of those people. So you can imagine that the number of people who do the labs will not be the same as the number of people who do the self-reports, and will not be the same as the number of people who do exams, right? The denominators will keep being different. So everybody, of course, everybody can do a self-report, right? It's just filling the form, no extra cost involved. But for logistical reasons, we can't say everybody, will have a lab or everyone will do an exam. So this is the reason why in NHANES you have different weights. So the questions that involve the self-reports will have a different weight. The ones that involve labs will have a different weight. The ones that involve exams will have different weights. Now, what happens when you're now combining information from labs with self-reports or exams with how do you determine what weight you should use? We're going to come back to that later, but keep this in mind, right? Don't forget this. We're going to get back to it and talk about it extensively because you need to know all of those things in detail so that you don't make a mistake. Because if you apply the wrong weight, all the analyses are completely invalid. You may have done everything perfectly, right? But by applying the wrong weight, it means your entire analysis are wrong. Your inferences are wrong. So you are just, yeah, this was just a side event, right? So we don't want to get into that trap of getting wrong estimates. So we're going to talk about how do you know what weight to use in your analysis of NHANES. And this is special to NHANES because, like we said, it's one of the few surveys that has that exams and labs and self-reports. So we have weight, we have a PSU. PSU stands for primary sampling unit. Primary always means the first. We'll talk about primary school. Primary school is the first school you go to. Talk about primary teeth. That's your first set of teeth that come out. So primary sampling unit is the first stage of sampling in a complex survey. So hence, for example, the sampling methodology is we first of all select counties. Counties are like the second administrative unit in the US. We have states and then we have counties within those states. So NHANES selects counties first, and then within those counties, they select households, right? So since the counties were the first stage of selection, we call those the primary sampling unit, right? In other words, simply put, the first stage of selection. So we have to account for that. And why do we have to account for that? Well, one of the problems of cluster sampling is, remember, in life in general, when we solve one problem, we end up coming up with another problem. The problem we're trying to solve with cluster sampling is that, geez, we want to draw a representative sample, but we don't have a sampling frame. We don't have a list of everybody who lives in the US, right? So our sampling must always be based on a list. We need to have a list before we can do sampling. That list can either be a list of people or a list of the places where the people live, right? And so we don't have a list of people, so we can go to the next best available option, which is a list of the places where people live, in this case, counties, right? Because our end goal is to find people. So if we don't have a list of their names, well, at least we have a list of where we can find them, aka counties or the clusters. That's the problem we're trying to solve. The second problem we're trying to solve is one of efficiency. And here, what we're saying is that even if we had a list of everybody, of course, you can be sure that the Census Bureau has a list of everybody who lives in America, right? Theoretically, at least we can make that argument. But even if we had that list, does it make sense? Remember that NHANES is, you are driving a bus. You have this long truck driving from household to household. Does it make sense that the truck will drive to point A and then go to another randomly selected household 10,000 miles away, across the desert? No, it doesn't make any sense. It will make more sense for us to find a way of capturing people who are together so that we capture them at the same time. So that logistically it's just easier to execute, right? And that's the second reason why we use cluster sampling. Because even if we had a list of everybody, it still would not make sense to be driving this big truck across the whole country, right? It would be easier if we went to one cluster and we say, okay, we're going to focus on this cluster and sample as many people as we can. And then we'll go to the next cluster and so on and so forth. So that's the second problem we're trying to solve. But like we said, every time we solve a problem in this world, we always introduce another problem. That's just the law of nature, right? There's no free lunch. So one problem solution brings about another problem which we have to solve. In this case, the problem we've brought about is the fact that people in a cluster tend to look like each other. They tend to resemble each other, right? People live in the same household. Well, they share habits, they share food, they share exposures, they share many things, right? And so they are more correlated. There's a correlation within that cluster. We call that intra-cluster correlation. And it's not just in the household. If you extrapolate, you can say the same thing applies to a cluster like a county. People who are sampled within a county, they look like each other. Now, that is not ideal because in general, we want to sample people who are very diverse, right? We want our sample to reflect the heterogeneity found in the country. And so that is why when we are doing our studies, we have to also account for the fact that people came from clusters and so they look alike. So remember, the fact that they come from clusters mean they look alike. That they look alike means that any confidence intervals from this group will be very, very narrow. And if the confidence intervals are narrow, that is not good because remember, narrow confidence intervals means that they are not likely to overlap. If you think of two very skinny confidence intervals standing side by side to each other, they're not going to overlap because they're so skinny. If they don't overlap, that means that we are likely to say, oh, they are very different from each other, but they aren't. They appear to be skinny, not because they are truly skinny, but because we use cluster sampling, where people in the cluster look alike. And so the confidence intervals are narrow. And so we end up concluding erroneously that estimates are different when they are not. So you can see how we've cascaded down from something that was, seemingly harmless to actual implications for our results, where we fall into type 1 error, where we conclude that results are significant when they are not. And that's the reason why we have to account for PSEs. And then strata, sometimes we stratify, like we said, we stratify to oversample within groups, right? The reason why we can oversample is because we first stratify. And so we have to account for that also in our design. So in your analysis of enhanced data or in your analysis of any complex survey data, you must account for those three variables, PSU, weight, and strata. The volume, if the weight variable acts like the volume control. It increases or decreases the sound of your estimates. So the estimates will be bigger or smaller depending on whether you weight them or not. However, the PSU and strata adjust the balance. So they have an effect on the confidence interval, right? So they can make them wider or narrower. So this is why you must account for all three variables. If you don't account for the weight, but you account for PSU and stratum, you are controlling the confidence interval, the width, but you have completely ignored the point estimate. If you account for only weight and not this, you will end up coming to erroneous conclusions that estimates are significant. So it's very important. The bottom line is that all the three variables we talked about, you must account for them when you analyze a data set like NHANES. It's just saying the same thing. All right. So weight, essentially what they do is to force our sample to, this is my favorite analogy of what weights do. If this is our parent population, this is the US, and this is our enhanced sample, what weights do is that they force this ugly looking sample that does not look like the parent in any way. And this is what the weights do. They take this, amorphous shape and create a pseudo population that kind of looks like the parent population. And now we can compare. So that's what weights do in survey. It's a way of allowing us to make inference. So again, remember, it's all about this cycle of inference. Or it always boils down to this. How can we make inference from the sample to the parent population? There's an assumption there that the sample kind of looks like a parent. If the sample does not look like a parent, then we have to weight the data to ensure that they do. All right. So we have our analyzed sample and then enhanced sample we're going to be working with is our analyzed population. So we have the bigger sample population which produces respondents, and then we have a target population, which is the United States in overall. So we need to understand this concept that the target population produces the sampling frame from which we sample, and from that gives us the analyzed population, which allows us to make inference back into the target population. Now, we should be able to know a little bit of, without going into detail, about weights and some rules. We're going to establish some rules of behavior for our analysis that we must not break, right? And this is also a validation for us when we are looking at data. We need to know where to look for. A good researcher should be able to spot problems. So you have a problem on your hands when your weights are 0 or negative. Weights cannot be 0. Weights cannot be negative. They have to be positive values that are greater than 0. So because a weight of 0 is like literally, we all have weight. Some of us suffer from, in fact, overweight. We have too much weight, right? A weight of 0 means you don't exist, right? That's what a weight of 0 means. And so no one in your data set can have a weight of 0, because in real life, no one has. If you're a weight of 0, that means you're dead and you've decomposed already. That same applies statistically. A weight variable, this is, a weight variable tells us, for example, that this weight of 4.19 means that this individual stands for 4.1 people like him, of course, himself included, right? That's what that value means. A weight of this guy here tells us this guy stands for 1,227 people, right? If you were to guess, this is now a pop quiz. Between this weight of 4 and this weight of 3,000, and let's use this one here. What was the big one I saw now? Let me just pick anyone. Weight of 4 and weight of 3,093. Which one of those? So row number 14 and row number 1, Which one likely came from an oversampled population? What are your thoughts? Row 2 and the big one and the small weight and the big weight. Which one likely represents an oversampled population?
Are you able to see the answers?
Oh, no, I'm not. I can't see the answers at all.
Oh, okay. There's 14, 2, 14, 1, big weight.
Okay. So, all right. So let's think of it from first principles. Remember that a weight means that U stand for X number of people. So let's take two populations. Population A has 10 people. Population B has 10 people. So they both have 10 people. For the first population, we oversample to the maximum extent possible, which means we selected 10 people out of the 10 people, right? So each person there has a weight of what? There were 10 people, we selected 10 of 10 of them. That's the maximum form of oversampling that we could ever do, right? Each person has a weight of what?
This one.
1. Second population, we selected only one person, right? We didn't oversample in this case. That person has a weight of what?
10.
10. So when we oversample, are the weights bigger or are they smaller?
Smaller.
Exactly. So, all right. So, clusters and strata, they sound similar, but they're very different. Strata means that, everybody's similar within the stratum, right? Like when we divide, for example, when we want to oversample, for example, minorities, we divide the country into, parts of the country that are, you know, dominantly Black, dominantly Hispanic, dominantly white, and we sample, right? That's what we're trying to demonstrate here visually. You have the black, white, yellow, blue, each exclusive, right? That's what strata looks like. The clusters, however, look more like a mixed bag. But the idea is that one mixed bag is similar to the next mixed bag. And that's the premise under which we do cluster sampling. The whole idea is that, well, if we have 4 mixed bags and theoretically one is similar to the other, do we really need to take all of them? Can't we just sample them, right? And then we can say, oh, yeah, that makes sense. Let's just sample 2 of them. With strata, they are very different. So it's all on, you can't just say, oh, I want to sample these two clusters and not this two strata and not these ones, right? What kind of bias is that? If you say, I want to sample this and this, but I don't want to take this and this, what kind of bias is that? It starts with the word none, N-O-N. None what?
Non-representative.
Okay? It's a C word. Non, I've already given you guys the answer. Non-coverage. That's non-coverage bias, right? Because your sample does not cover everybody. So that's why we call it non-coverage. And so the point here we're trying to make is that once you stratify, you must sample from each stratum. Otherwise, you end up with non-coverage bias. All right. You cannot delete rows. I cannot stress enough. When you're analyzing complex survey data, you cannot delete rows. Let's look at what that means. Here I have my data set, and I wish to analyze data only among boys. There are 2 boys and 2 girls. So that means that there are a total of 4 rows in my data set. What is the wrong way of doing the analysis? The wrong way is to now drop all the girls so that my data set has 2 rows and then I analyze the boys. That's completely wrong. You are going to get, so can somebody explain why this is wrong? Remember we said that you are always going to get that our results here. Let's go back to this picture. We're always computing two things: the point estimate and the measure of variance. In this case, 95% confidence intervals. Let's freeze this in our minds, right? And now we're going to go back to that slide. So again, remember the point estimate and the 95% confidence intervals. When we do this, we calculate blank correctly, but calculate blank incorrectly. Who wants to fill in the gap for us? When we drop rows like this, blank is calculated correctly, but blank is calculated incorrectly. Any takers?
Point and confidence intervals, weights collected incorrectly. Sample variance decreases.
Okay, no, remember the two issues here, the point estimate and the confidence interval. Which is correct in this kind of scenario and which is incorrect?
Correct point estimates, but wrong confidence intervals.
Excellent.
Point estimate correct.
Very, very correct. So the point estimate in this case will be correct. The confidence intervals will be very wrong, right? And this is because when we do complex survey analysis, the point estimates are always calculated only among the subset. So that means that if we're analyzing boys, the point estimates will always be calculated only among boys. However, the confidence intervals must always be calculated among the entire population. So in other words, we're using the PSU and stratum information for everybody, but the weight variable is applied only to the subgroup of interest. So it's as though those ones had a weight of 0, right? This is the reason why we cannot drop rows. This is a fundamental rule. You must not drop rows, right? You must not delete rows. You have to use the special methods for analyzing that. And that's what we're going to be showing in tomorrow's session, right? Today, we just want to set a very strong theoretical basis so that we all understand the do's and don'ts, and we are all on the same page as to why we're doing things. So it's not enough to just know how to click some things and get an answer. We need to understand why. Like, why is that wrong? Or why is this correct? So that's what we're trying to establish today. So if you're using weighted, so best practice for weighted analysis, if you analyze the data set like in NHANES, in your results section, please stop saying of the 5,000 people who were analyzed in NHANES, 20% were smokers. That is wrong. Again, why is that wrong? Let's go back to this cycle of inference. This cycle. We got an NHANES sample here. Once we weighted the data no longer speak for themselves. They speak for the population. So when you say that of the 3 people who were analyzed in NHANES, 2% of them were smokers, that is completely wrong at this point, right? Once you weight the data, a miracle happens. The miracle that happens is that the sample stops being a sample and grows into the population. So instead of saying of the 3 people who were analyzed in NHANES, you will say of the US adult population, 2% were smokers. I hope we all get the nuance. It's very nuanced, but it's extremely important to making correct interpretation of results when we analyze data sets like NHANES. The inference is to the population, the target population, not the sample that we just analyzed. So back to this, yes. And generally, we try to suppress estimates with relative standard errors of more than 30%, or those that were calculated from less than 30 people, because they are imprecise. Again, do not delete rows. I should create a song for that and play the song to you and repeat, because it's very, very important. Again, the second worst thing you could do is to fail to account for weight. I just highlight this just to show it, just to share lessons so that we can just remember. You don't want to publish a paper and then say, oh, geez, we were actually supposed to weight that data and we forgot, right? So here the authors say, oh, following the publication of our article, we noticed we had not considered sampling weights of complex survey design. Well, this is why we're having this class, right? And that's why I'm emphasizing this, so that you don't just take the enhanced data set and analyze it as though it was a simple random sample. It is not. You're going to get results that are invalid. So I can't stress that enough. What happens when you ignore weight, right? Let's look at it just from a small perspective here. When you generate estimates, what the software is doing in its background is, this is a very simplified version of it, but just to help you understand what's going on. This is 1 times 10 plus 2 times 100 plus 3 times 1 plus 4 times 10 plus 5 times 1000 divided by the sum of the weight. That's what your software is doing behind, right? And you get this estimate here, 4.7. When you fail to account for the weight, what you are saying in effect, you're telling the software that everybody has a weight of 1. Unweighted analysis is the same as saying everybody has a weight of 1 or has the exact same weights, right? So in this case, you are saying 1 times 1 plus 2 times 1 plus 3 times 1 plus 4 times 1 plus 5 times 1 divided by 1 plus 1 plus 1 plus 1 plus 1. You get a result here is 4.7, here is 3.0. Obviously, 4.7 is not 3.0. In our case here, the difference is not exaggerated because this is a toy example. But that's just to show you how things can go bad when you fail to account for weights or the complex design when you ought to have done so. Your result will be invalid. So again, don't make that mistake, please. Now, what type of weight should you choose, right? So remember we said that I told you to freeze a picture in your mind and we're going to come back to it. All right, well, this is where we've come now. Remember we said that NHANES has 3 modalities for data collection. You have self-reports, labs, and exams. All right. Now, because of the 3 different modalities, it means you have different number of people in each sample, right? You have different number of people for self-reports, different number of people in the lab, different number of people in exams. Now, to make it easier for us to comprehend, I have another analogy here to the right-hand side. You have 3 scenarios, 3 sets of people, and all of them are under an umbrella of the exact same size, right? Because remember that all the weights, if you add all the weights, they will give you the total population, right? So all this weight that was mentioned earlier, if you add all of them individually, you're going to get the total population, right? That's the magic behind weight. And that's why we say the umbrellas here are the same, because regardless of the weight from this or this or this, if you add the weights, you're going to get the exact same population size. So that is why this is a very important part of our analogy, right? That the umbrellas are of the exact same size. But now the people under it are different. You have 10 people, 5 people, 2 people. Where does it make sense if you are going to stay in an umbrella, if you're going to use an umbrella, where does it make sense for you to go to stay under? That's a pop quiz. Which should you go to? Or which way is it reasonable for you to go to? Just from basic plain communication here. What are your thoughts? Okay. So I see most people say that yeah, you go to this umbrella with 2 people. And that's absolutely correct. Oh, I hear some people saying the middle umbrella. 5 people. Well, why would you want to go to the crowded umbrella, right? You want to go to the umbrella that's where you can be accommodated. So just freeze this image in your mind, right? So what we're saying is that in your hands, you want to use the weight that has the smallest sample size, right? So if you have a if you are merging data sets from the self-report with 10,000 people, and you're merging data with a lab marker, and using your outcome is the lab measure, right? Should you use the weight for the self-reported, or should you use a weight for the lab? What do you think? Exactly. You should use the weight. Absolutely use the weight. So you always go to the umbrella with the smallest number of people, right? Don't go to the crowded umbrella, please. It's crowded there already. Okay. Go to the umbrella with the smallest number of people. That's where you're going to be accommodated. So, and this applies to when the outcome, right? This is in consideration to the outcome for your analysis. So if you're looking at if you're combining data from labs and from oral exam, or from, why do I keep saying oral exam? It's very clever dentist, right? If you're combining data from lab and exam, and let's say the exam has 2,000 people, this is just hypothetical scenarios. You have 2,000 people here, you have 3,000 people here. Which weights should you use? 2,000 here, 3,000 here, right? It's clear that you should use, again, always go to the umbrella with fewer people, right? That's the point we're trying to make. So if you find how to remember, just freeze this mental imagery in your mind, right? So that always guides you in selecting the right weight. This is so important. I cannot emphasize enough. If you use the wrong weight, your analysis will be completely invalid, right? So you would need to absolutely know what the outcome of analysis of interest is and where it came from. Did it come from self-reports? Did it come from exams, or did it come from lab? You must use the correct weights, or else your analysis will be invalid. So that's another very important rule we got to remember, right? Use the right weights. Remember, first of all, said use weights. But it's not enough to just say use weight, right? Use the right weights too, because you will find different weights. And it's good because NHANES always makes it very clear what the weights are. You can, just by looking at the weights, you can tell. For example, weights from interviews will have the word INT in them, weight interview. So now that does not absolve you of the responsibility to go and read the documentation. You must read the documentation to know what it's saying. But what I'm also saying is that just by looking at those variables, you can always tell which weight it is. Weight from a medical examination center will always have MEC, Medical Examination Center. Weight from interview will always have, so you can't miss it. So it's your job to know which where your outcome measure came from. All right. Another thing we need to know is merge and append, because NHANES, like we said, the wheels on the bus go round and round. They go and collect some markers there. Meanwhile, somebody else somewhere else is collecting data on something else. So as you can imagine, NHANES data sets come in small little different pieces, right? So sometimes, well, not sometimes, almost every time you'll have to piece together the data sets together, right, to be able to analyze it properly. So we have to understand merge. We have to understand append. Merge is when we take the oral exam data from the same individuals and append and combine it together with the demographic information from the same individuals and combine it together with the lab. So remember, 3 sources of information: self-reports, labs, medical exam. So we want to piece together the information for the same individuals so they have a complete data set. That is merge. Append is if we now want to say, geez, we want to increase sample size for our analysis. So we're going to stack together the data set from 2004 to 2006, 2008, so that we have a bigger data set. That's append, right? So you absolutely need to know the difference between append and merge, because you're going to need it. You may not need append so much if you're just focusing on 1 year in NHANES, but if you're going to, if you're going to do any kind of analysis, meaningful in-depth analysis and NHANES, you can't avoid using merge. So we got to know it very well. All right, so in honor of all the dentists in the audience, I decided to use a case study based on oral disease, periodontal disease in NHANES, which we're going to use for our case study. So let me quickly pull up the case study, and we can look at how that works. All right, so This is the case study we're going to try to reproduce. It is an MMWR. MMWR is Morbidity and Mortality Weekly Report from CDC. And it's titled Periodontitis Among Adults aged 30 years or older, United States, 2009, 2010. The enhanced cycles are that it's an annual survey, but typically each cycle comes like this. So this doesn't mean it's 2 years. This is still one cycle of enhanced. We'll get to that in a minute so you can see what I'm referring to. All right, so what we're going to do is to see how we can replicate the same results. So for today, what we'll do is to look at the data sets in NHANES, look at how the different components are structured, and see how we can recode the variables, right? We're going to prepare our data sets for analysis tomorrow. So we're going to prepare these variables by recoding them as appears in this MMWR, and we will then, take up the analysis tomorrow. We'll also try to do the merge. This particular MMWR focused only on one cycle of enhance, so we'll just try and do the same, but we'll show in broad principles how you can do that. I have tried to create some, we're going to use the chi-square platform for analysis, but I recognize also that some people may wish to do the analysis elsewhere. So for that purpose, I have tried to be very broad in the materials we prepare. So you have a bunch of materials here. You have the code for, again, for those who want to use whatever software to analyze their data. We have code the code for generating the same MMWR here in R and SAS and in Stata, which we're going to share with you. So this is in SAS. For those of you who are old school, and then in Stata, for those of you who are, well, what kind of people use Stata? I don't know. Well, most people who have been taught from the schools, most people pick up Stata from their grad school. All right, so that's what we're going to do. I've also prepared a guide, a step-by-step guide, so that if you are trying to replicate these estimates, you can then find some guidance there. So that way, yeah, we're going to share all these documents with you. We're going to put them on our LinkedIn post, our LinkedIn page, so you can access them from there. No, so please make sure you can you have our LinkedIn page, so you can grab the documents accordingly. All right, so let's get started. So so first things first. So I've prepared. I'm just going to go through the manual quickly, but I have prepared in such a way that it's pretty easy and intuitive for you to just replicate step by step. I think in general, people find it easier to do things when they are listed step by step by step by step. So that's what I've tried to do in this report. So that it's easily digestible to you, so that you can always find your way. So step one, download the different data sets from the NHANES website. So it's that simple and that plain. So here we have, let's look at the data sets. Let's go there. Let me open a new tab so we still have our document there. All right, so this is the demographic data for NHANES. So like remember we said the NHANES file don't come as one large, massive file. They come in small chunks. So this is the demographics data for NHANES. Our MMWR is from 2009 to 2010. So this is the year we're interested in. Each file comes with two, you guys can see there are two links. This first link is the documentation. Please, I beg of you, you should get into the habit of reading documentation. That's very important, right? Your job as scientist is twofold. You must be able to write good documentation when you're writing code or when you're writing any methodology. you should be able to produce good documentation that others will read. And then two, you should be able to read documentation. So you should be able to read and write. So that's very important, right? So please don't just take a data set and jump into the analysis without having read documentation that provides the context for what is being covered. So 2009 to 2010, this is the demographic variable. And so this is the documentation. This is the data set, right? So if you click on it, you would see that it opens up as a very terrifying structure, right? And don't worry about this. This is an XPT format. It's not designed to be human readable. It's designed to be machine readable. So it's completely fine if it does not make sense to you because it's not designed to make sense to you. So the enhanced files are stored as XPT. XPT is a SAS transport file. So the X is, cross portable transport file. So it is a form of data storage that allows files to pass from one software to the other software. I will show you the wrong way to read it. That I've taught courses with Enhance for many years, and this is the wrong way people read the data. And then I'm going to show you the right way. So please don't do this, right? You want to read it as an XPT file, not as a TXT file. So when you open it, the file here, and you attempt to save the page, you are likely trying to save it as a text file. So you see that this is a text file. That's not what we want to do. No, we don't want to read it as a text file. We want to read it as an XPT file, right? So read it for what it is. So please, we're going to go back here. And what we're going to do is to right-click on the link. And we're going to click Save Link As, right? So that's what we're going to do. So instead of just downloading the stuff, we're going to do this, and let's create a document upstairs in our desktop, and let's call this .xpt, right? So that's what we're going to do. So let's look at how do I show this now? If you have your computers on, you should absolutely be doing this alongside me so that it makes sense to you. If you're in a position to do so, so that down the line you might forget, okay, how did you do it? So if you can, again, you would select it and you save the link as, right? And then remember to make sure that you put .xpt. That's very important. This is the file I just saved now. You can see demo.xpt. That's the file right there. So again, in recognition that there are some of us who might be using different software, I'm just going to demonstrate to you how to read a .xpt file in different environments, right? So that you can be able to read it successfully. If you are, do we have Stata users? If not, we can just move on to, if you use Stata, you can the command to import XPT files into Stata will be FTAUs, right? So you put that and then you provide the link for the file path. So in this case, let me grab the file path here. Oh, so sorry, I see some messages. Let me drop the link to this page on our chat down here. All right, so you can again type FDAUs and then type the file path which is in this case, I hope you can get it. How do I share the screen? Well, I assume you're not that. Let me just do it so that you know well. Let me not assume knowledge. So you click on the file you've saved. You click on properties to look at get the file path. So again, click the file, save it. Once it's saved, you right click on that file, select properties, and you can then copy the link. So this is the link I have copied. I'm going to paste it here, / the name of the file. It's not enough to just copy the file path. You also have to copy the name of the file. So there are two places that you have to copy, right? Is anyone confused about that? So FDA use then the file path as well as the name of the file. This is the file that we saved. So that is how you import an XPT file into Stata. If you're using R, you would have to install the library for the foreign library, because of course, obviously, XPT is a foreign library. So if you don't have that already, you have to first of all install it, and then after the installation, you have to call the library, right? Library foreign, and then you can then read the file. So read.export, again, export file. So that's how you can read it in R. All right, that provides a quick overview for those of you who are using Stata R. All right, but the rest of our session will be on the KNHANES platform. But we just wanted to show that courtesy for those of you who might be using other software. So on the KNHANES platform, and for those of you who are not familiar with the KNHANES platform, it's a one-stop shop for research. So you can collect your data, analyze your data, and all of that. So we'll be doing the rest of the activities on the platform. So to get to the platform, you'd simply go to www.chiquest.com and you log in if you have an account, or you sign up if you don't have an account. So the manual that provided here provides the step-by-step guide in, I believe this is Stata, but we're going to replicate that. We're going to share this guide with you, but we're going to replicate this so that you can see how you can do the exact same thing on the KNHANES platform. So first of all, what we've done now is we've downloaded the demographic file, which you have access to now. We have read it into Stata and R. We're going to read it into the KNHANES platform. So here, I will come to data analysis, and I'm going to start a new project. And I'm going to call this Enhance Analysis. And that description, which is optional, but I will just type, and this is to replicate. This is day 1. This is to replicate the findings from the CDC MMWR with enhanced data. All right. So whatever you can do on Stata or R, you can also do it on the KNHANES platform, although this is a way simpler way to do it. The KNHANES platform literally was designed for an 8-year-old mind in view. We said, okay, how do we make the analysis so simple that an 8-year-old child can do it? So it's super simple. So upload data sets, you can select which file you want to upload. So in this case, I wish to upload the demographic data set. So I'm going to simply select that, and so that's the data set in here. So you can then explore. So this is it. So it's as simple as that. No need to write code. No need to jump over hoops. The KNHANES platform allows you to import data in whatever format like we really don't care what the format is, whether it's expertise, SAS transport, a SAS 7, a SAS analysis file, whether it's SPSS or whichever file format, you can read it into the platform. All right, now let's proceed with the other aspect of the step-by-step guide. So let me just pull this into a different page and pull it out. So we can just be shunting between the two. All right. So this guide was written a long time ago, for my students at Harvard, a long, long, long time ago, but it's still relevant. So no updates were made to it. We're also going to prepare a similar guide for the Chi-Square platform so that you can also compare side by side. All right, so we're going to go ahead and do all the recodes needed on demographic file, and then we will then proceed with the rest of the file. So we have read the data set in. Now let's go ahead and recode variables that we need. So we have the variables like age. So these are all static commands, but we're going to do them on the Chi-Square platform accordingly, in the exact same way. So first we have to recode age. So let's do that. The variable is this. So let's do just so. But first, let me walk you through the Chi-Square platform in terms of the analysis. The analysis you have, this is the code book. The code book allows you to view your variables and let me make this bigger. So you can view the variables you have. On this view here, you have the variable name, the variable type, the number of unique values, and any number of missing values that are present. So here you can see that this variable has 5,049 missing values. For each variable type, you can visualize it. You can click here to see its visualization. And that will depend on the variable type. All right. So if you have a visualization, you can also choose to change the type of display for it. You can choose to change it to a column chart or to change it to, for example, an error column or any other type of chart that you wish to visualize. The visualization obviously will be different if it's a categorical variable versus some other type of variable. If, for example, it's a string variable, it will be different, right? Because that's a different variable type altogether. Okay, we don't have a string variable type here. So here you have a bird's eye view of the variable type. You also have the summary statistics. So if you click here, that gives you the summary statistics for the variable. If it's a discrete variable or categorical, you have the values, the unique values, and as well as their counts and percentages. If it's a continuous variable, like this one here, what you'll have will be the mean, the standard deviation, as well as the 5-number summary. The 5-number summary at the minimum, maximum, Q1, Q2, Q3. Of course, Q2 means the median. So that's what you would have, right? So it's contextualized to the type of variable that you have. So there are major buttons here. Let me quickly walk you through the whole thing. Replace is if you want to change the data set. That allows you to replace. You can rename your data set. You can call this demographic data set, if that's what you want to call it. So that's how you rename. You just click in the file and rename it. The replace, like I said, allows you to replace an existing file. Preview allows you to see your data set in spreadsheet mode. And so you can look at all the the variables that you have in the spreadsheet mode. If you want to make edits to a value, you click on edit data set and you can edit the value as needed. You want to be very careful before you edit values, right? If there has to be a real reason for you to edit them. The platform also logs all changes made to the data set so that you can see them in real time. If you're just interested in some basic descriptive statistics, you're not interested in any deep dive into the data, you just want some high-level summaries of the data set, you can click on Descriptive Statistics Report. The platform takes that information, takes all the variables and just summarizes them for you as tables and figures, depending on the type of variable. So that is there for you in case you're just interested in, oh, maybe I had a survey and I'm just interested in the overall summary estimates for the variables in there. You can also download the results as a PDF. And then you can also export your data. You can export data into one of different formats. We support the Packet format, Excel, CSV, and JSON. So that's that for there. If you have done analysis, you can look at the history here. These are some of the things we've done. We've visualized. So each action you take is logged because research has to be reproducible. If I did something, I want to make sure that I can remember what I did. So that's why you have a very detailed history. Then these 4 actions here are to provide guidance in, data management. So the data processing allows you to do all manner of processing, whether it's rename a data set, to respecify, to clone a variable, to cross-tabulate, split, and so on and so forth. You can also recode, you can do various types of transformations. Then you have also data set actions like to replace data set, to find and replace, to delete records, to create calibration weights, to combine data sets, whether it's append or merge. Remember, we talked about append and merge. Well, we're going to come to this in a minute. But that allows you to do whatever kinds of changes or modifications you need to do on your analytical data set. So that's what you have in data processing. Estimates, we're going to be using estimates a lot. It allows you to generate estimates for whether it's regressions or prevalence or estimates or means or whatever the case may be. Test allows you to perform statistical tests, parametric tests, non-parametric tests. And the analysis wizard is really where you want to stay if you don't know what you're doing or if you're not really sure of yourself, right? It provides it assumes that you don't know, it assumes you don't know anything you're doing, and it provides that guidance you need. So for example, if you wanted to do a statistical test, let's say I have a variable like this variable, let's say, and now, good. I'm going to digress. Allow me to digress. But I saw these 2 variables, and I just wanted to really bring your attention to it quickly before I went and selected my variables. You can see these variables. These are the weight variables in NHANES. You can see how explicit they are. WT stands for weight. MEC stands for Medical Examination Center. And the 2 year talks about the aggregates of the data that were aggregated, right? So just at the glance, this one stands for the weight, WT weight. INT is interview. So again, back to what I was saying, that it allows you to really, you can just at a glance know what they are. All right. Thanks for the digression. Now let me go back to what I was saying earlier. If you want to do a test, let's say I want to say, oh, does the weight variable differ by, let's say which other variable here? Let me see if there's sex here. I'll just pick any random variable really here. I want to see whether the variable, the weight varies by this, right? And this is another. I don't know what those variables are. I just want to see is there a difference? I want to do a statistical test, or my supervisor told me to go and see whether there's a significant difference between this weight variable by this. All you have to do is just select the variables you want to test and click on run. The platform takes that information that you have supplied and looks at its own decision tree and says, well, here you have a continuous variable, and here you have a variable that has 2 unique categories. If I'm supposed to do a statistical test, well, that has to be a 2-sample t-test. The platform does a lot of things in that split seconds. It's looking at the type of variable you have, whether they are, for example, categorical or continuous. It's looking at the variances. For example, when we have, for example, one categorical and one categorical variable and a continuous variable, the kind of test depends on the variance between those 2 groups, right? If the variances are equal, then we use a 2-sample test. right? If the variances are not equal, then there's different tests we use entirely, right? The wedge tests. The platform does all of those tests in the background before recommending that, okay, this is the correct test for you to use. So it recommends a test. It gives you the rationale for the test that is recommended. It then proceeds to do the test, provide you with all the results, and let's say the p-value, and also interprets the results for you, right? So here it says that the two-sample t-test was used to test the null hypothesis that there is no significant difference between the means of two independent samples against the alternative hypothesis that there is a significant difference between the means. The mean of weight mech 2-year was significantly higher among group 2 versus 1 of read star, and these are the values. The t-statistic was this, and the p-value was this, right? So if you don't know what you're doing, this is what the analysis result is supposed to do. It's supposed to help you to find your way. So whether you want to run a regression analysis and you don't know what kind of regression that is supposed to be run on that particular variable, or you want to write a manuscript and you have never written a manuscript before, right? You come to the analysis suggester and you tell it, well, what's my outcome variable? We're going to do a little bit of that, in the future. But again, the point I'm trying to make is that if you don't know what you're doing, you should just stick around here. The platform will provide you with the guidance that you need. So that's about that. But for now, let's go to our recode. Let's recode our variables and where is my manual? All right, here it is. So we want to recode these variables and then we want to see, make sure that they are, in alignment with what we need them, the way we need them to be. So the first variable we want to record is age. And this is what it looks like. So let's go back to here. Let's go to data processing and then recode. The variable we want to record is read RIDEH. I believe it's this one here. Let me confirm. Read age year. Read age year. All right, good. So this is the variable we have here. Now, on the KNHANES platform, for everything you're doing, there is the easy way and there's a hard way. So for those who want to suffer, we always recommend you to go to the classic method, which is the hard way of doing it, right? But for those who do not want to suffer, there is the easy way, which is a visual method. I love the visual method because, well, it's visual. I can see what I'm doing. I can see things in color. Life is already hard enough. So it's, some splash of color is always good. And apart from color, it's also animated. So you can hear sound effects and vibrations and now if that kind of thing bores you or it's against your philosophy, you can always go back and use the classic method, which is of course, we couldn't call it the boring way, so we'll call it the classic method. All right, let's be more serious and look at our recode now. Now, we want to recode this 0 to 29. So here, it's simple, you simply just look at where you want to recode, right? We want to split it at 30. You can change the settings such that you control where the cutoff is. My settings allows the cutoff to be in the next category. So that means that I'll have to specify 30. So in this case, I want to recode, is that the variable? Read age year. Let me make sure that we're recording the same thing. So 0 to 29 equals 0. Okay. And then the next cut is from, so you essentially just click where you wish to split. If you want to resize this, you can come here and say resize. So the minimum, whatever the minimum is to whatever value you want, right? And that's how you wish to, you can do it. So from 0 to 29, then the next cut will be at from 30 to 34 again. So we'll come back to here and we can cut wherever we wish to cut, right? So that's how the platform allows you to record your variables. Now, we can also look at it from the visual method, right? If we're not interested in let me just give you a flavor of how the classic method looks like. So for the classic method, let's select this so that you have options to create your variables. So here you specify the variable. So here we can say a value of this variable is less than or equal to, then you enter the value. For example, if it's less than or equal to 29, then you change the value to be, let's say, whatever the name of a group you want to give it to, right? That's how you can use the classic method. But again, like I said, I always prefer the visual method. So I'm going to go back to that so we can just create our variable that way. So let's go ahead and create, finalize this variable. So we have 29, let's split. And then from the next group to 34. And then the next will be to 49. And you can always, if you're not a big fan of the sound effects, you can always mute them. You can mute the sound effects and the color effects if you don't want them. And then the next will be from 50 to 64 to up to 64. All right. And again, like I said, so now we've split that continuous variable into groups. You can always resize the groups if you want. If you can always align or change the beans by coming to more actions, and you can edit the label. Sorry, not edit the label, the resize. You can resize and you can say, okay, I want from the minimum to whatever it is you want, let's say 29. So if I want to go from the minimum, this tells me the minimum age was 5.397, whatever. So I can always resize by being very specific. So now this takes it from this value to 29, from 29 to, again, you can resize to whatever groups you want. So I want to resize this to 34 if that's what I want, right? So we're just making this change so you can understand how it works. So 34. And so as it resizes this group, it makes a corresponding change to the next one. It picks up the next available value and adjusts the next one accordingly. So I may want to resize this one to, if I wanted, to 49. And you can always change the settings so that you control where the cutoff value resides. I just prefer the cutoff value going to the next one. But those are all things you can change in the settings. And then from this to 64, all right, so here I have effectively created my age variable in categories, and I can give it a name. I can call it, the name age cat. So let's do that. Age cards. And if you want to replace the original variable, you can click this button. I'll strongly discourage you from replacing original variables in your analysis, because the question is, what if you made a mistake? What if you need to go back to that same variable? Then you are really, really lost. So always create new variables, not replacing original variables. So we're going to generate a new variable and not replace the original one and create that. All right, so we have done one variable. Now let's create the second one, which is sex. The variable name is React gender. Let's look for it. React gender. So this is it right here. So we're going to recode it. And here the recode is simply, 1 is male and 2 is female. So 1 is male, edit the label, male. So one of the beauties of the visual method is that it picks up colors from the context. So when I type male, it says, okay, well, it's assigned the color of blue. Again, which it doesn't change anything, but it's visually appealing, especially if again, remember we targeted the platform for a child, so we make it visually stimulating and exciting. And 2 is female. And the new variable name is called sex. So we're going to call it sex, and that's how we finish that. Then the next variable we have to recode is education. So DMD educ2, that's the name of the variable, educ2. We're going to recode this. We're going to have, it says 1 and 2 equals 1, which is 0 to 11. So 1 and 2, again, with the visual method, again, it's all about just drag and drop. It's very intuitive. So 1 and 2, just drag 1 to 2. And we're going to call this, edit the label to say 0 to 11. Then it says 3 is high school. So we're going to call this 3 is edit label, high school. Then we have 4 to 5 is greater than high school. 4 and 5 is greater than high school. The platform doesn't care whether you put spaces or things of that nature, so that it's easily human readable. And then 7 and 9, I'm missing. So we'll put them into missing. So and that's how the platform allows you to recode. So again, we're going to give this variable a new name. The new name will be educ3, since it has 3 categories. So let's give the name as educ3. All right, then next variable, and then as you recode, as you generate new variables, you find them at the top. So it's easy for you to keep track of what you have done. All right, then the next variable we have to recode is poverty level. So let's do that. So data processing, recode. So you can select the recode either by coming to the very top up here, or you just select it from beside the variable. So poverty level, this is INDFMPIR. INDFM. So this is the variable here. We're going to recode it. So this is a continuous variable. So 0 to 0.99 is 1. And then the next cutoff is 1 to 1.99. Then the next one is, so if you want to type exactly 1 to 1.99, you have to change your settings to make sure that the cutoff value belongs to the lower group. In my settings, it's in the upper group. So that's why from 1 to 1.99, I say 1 to 2, because then the 2 belongs to the next group. but it might just be easier for you to change it this way. Well, it depends on how you see the world or your preferences. The next is 2 to 3.99. So from 2, and you can click anywhere. It doesn't have to be precisely at that point, because after all, you still have to supply the cutoff. You still have to verify the cutoff. So from this to 3.99, I just click somewhere around there, 3.99, which is like 4. And then lastly, from 4 to maximum. So from 4 to maximum. Now I can just change the labels to call to what we have here. I'm just trying to make sure it's exactly what we have here, so that if you're comparing, it's easier for you to follow. So that's that group there. And then okay, sorry, this one, edit label. Then 200 to 399 federal poverty level. These are poverty thresholds, by the way. Federal poverty levels. They're based on the poverty thresholds from the previous year. But let's not go into the weeds with that. Edit label. And then lastly, this one. All right, so we're done with our recodes. Now we can give the new variable a name, which is PIR. So again, that's the whole essence of the KNHANES platform. Like, how do we empower people to do whatever it is they need to do without having to write a line of code? Right? Surely, ability to generate insights or to generate knowledge should not just be limited to those who can write code, because a lot of people want to do good work, but just for the sake of they can't write code. I mean, and not for want of trying, right? And then there are some who think they know how to write code, but they just don't, right? So how do we then empower people? So that's the whole basis behind the platform. All right, let's look at the last variable. So race ethnicity. I believe we haven't we created this. Read ref. All right, race ethnicity. We recode this. 1 and 2 is Mexican American. So 1 and 2. It's Mexican American. So rename, edit label, Mex. Then 3 or 2 is 3 plus, then the next one is white race. Then 4 is black. And then the last one is, let's see, 5 is other. And we can now call this race. What name did we call it in the other documentation? We call this race 4. And we'll just proceed. And then I think we have one more variable to create. So okay, this is in the demographic file. So that's the next variable is in the other file. So that's how we can recode variables, right? To to merge variables, now we have to now go back to documentation and look at the next file, which was the oral health and then the smoking, cigarette smoking, right? So let's look at this one first. Again, takes us to the variables, to the list of items here, and then we can look for the smoking. So you can see the wealth of information, right? NHANES is a two-edged sword. On one hand, you have just so much information. Look at all this information. And then, and then on the other hand, you have just so much information. that its strength is also its weakness, right? It can get overwhelming if you don't know what you're doing because there's so much you can look at, right? So here I'm just look for Ctrl F, smoking, right here. So here we're interested in this file, smoke F, right? SMQF_F. So again, to download, you're going to right click and we're going to save link as. I hope you all remember the drill. When the goal is to avoid saving it as a TXT file, but to save it as a SAS, an XPT, right? XPT is a SAS transport file. So that's the goal, right? So we're going to save this file .xpt. So always remember that, just always, when you're saving that file, always remember to type .xpt at the end, right? So now we can now come in and import our data set. Now we want to, so we have a demographic file here. This is what we have. Now we wish to have the other data set, which is the smoking file. And so we'll come here to data processing and we'll come to combine data set. So we have the demographic file we're working with. Now I want to combine it with the other one, which is the smoking file. So combine data sets, and we're interested in merge. See, merge same individuals, append different individuals. It's pretty straightforward, right? So for same individuals, we're just going to click this file. This is the file we have. You can see it says current. This is the current file that we have. Now we wish to bring in the other file so that we can merge them together. So I'm going to click on upload and click on the smoking file that we wish to upload. Let's look for it. And so we can then choose a variable. So when we are merging, to do a merge, you must have a unique identifier that is common to both files, right? There must be a unique identifier in file 1 and file 2 that links the same. Remember, we're trying to bring data for the same individual together. So how will the system know that it is the same guy that's in row 1 that should be linked to the guy in another data set? It does that by the unique identifier. So the platform has you select a unique identifier for the first data set and for the second data set, right? That indicates that this is the same individual in the respective files. So you must, and this is why you have to read the documentation to know that this is the same individual that is here, that is also here, right? So, but that's what is required before you do a merge. You don't have to sort data or do anything fancy. The platform does all of that automatically. All you have to do is know this is the unique ID here, and this is the unique ID here, and then you click on merge. So the data set has been merged successfully. So now we can now proceed with creating the other variable of interest, which was this one here, the smoking variable. This one right here. But before we do that, let me walk you through some things that just popped up so you are familiar with them. whenever you upload a new variable, whenever you upload a new variable into the platform or you change the dimension of the data set, like append or with merge, this will always pop up. The platform will always ask you, do you want to set your analysis to weighted mode? Right now, you see that our analysis says unweighted, right? We have not set weights. This is very important. And the reason why it does it every time is that so you won't say, remember that document, that erratum I showed you where they said, oh, we did not know that we were supposed to weight the data. Well, you can't miss it here. You really can't. So if you want to set, yes, I want to set weights, you can, when you click there, it allows you to select the weight variable. So for example, my weight variable might be this medical exam. My PSU variable might be this one. And my stratum variable might be this, right? And this is all you have to do. This is the most complicated thing you have to do for analysis of complex subjects on the Chi-Square platform. Once you do this, you are all set. You don't have to do any other thing again. From now henceforth, the platform knows that every single analysis that it is doing must account for the complex survey design. And that's all you have to do. So every single thing we do, every test, every estimate, every calculation, the platform will automatically account for those design. You don't have to start worrying yourself like, geez, um, which is quite a different philosophy from, let's say SAS or Stata or R. In this all this other software, if you are analyzing data, you have to specifically indicate commands that indicate every line of command, every statement must account for that complex survey design manually. So that's a different philosophy we've adopted here to make life easy for researchers. Like you don't have to worry about every single line having to put to account for every single thing you do, because you may not even know the appropriate command, right? Because each command is different. The command for doing chi-square tests with weighted samples is quite different from the one for doing the same chi-square test with unweighted samples, right? And you may not even know that that exists. So this is to prevent mistakes from occurring. So tomorrow we're going to do a deeper dive into now generating the estimate to say, all right, now that we've done the complex survey weighting. How then do we generate estimates and how do we interpret them? Then before we leave, I want to quickly generate the last variable for our session, which was the current smoke. So current smoking variable was derived from two variables, this SMQ020 and SMQ040. Let's do that quickly. So we're creating the composite variable, because here we're creating the variable current smoking from those two variables. So let's see how that works. We create composite variable here. So you come to data processing and you come to create composite variable. A composite variable simply means, as the name implies, a variable that is made up of two or more other variables. So when we take two variables and we get information from them to create one variable, it's a composite of the two or more. So we're creating them using conditions. And the variables we're interested in are SMQ 020 and SMQ 040, I believe. Let me verify that so we're not making a mistake. So I believe it's SMQ 020 and 40. So SMQ 20, yeah, exactly. Yeah. So here, so and again, the instruction here says the case definition for smoking status. Current smokers have smoked 100 cigarettes in their lifetime and smoke every day or some days at the time of the survey. Former smokers have smoked 100 cigarettes in their lifetime, but no longer smoke. Never smokers have not smoked up to 100 cigarettes, right? So when we look at this information here, 2009 SMQ, let's look at the documentation, just so that we get into the habits of always reading documentation. So let's practice what we preach. So let's go to that documentation and see how you should be able to look up for those things yourself. So SMQ. So again, this is the documentation, right? This is where that information came from. So I didn't just create it from nothing. It came from this documentation. So you see SMQ020 smoked at least 100 cigarettes in their lifetime. So this is where we're constructing that from. So it says, have you smoked at least 100 cigarettes in your lifetime? Yes or no? Then SMQ040 says, do you now smoke cigarettes? So we define current smokers as those who have smoked at least 100 cigarettes and smoke every day or some days at the time of the survey. Former smokers are those who have smoked 100 cigarettes but no longer smoke, whereas never smokers are those who have not smoked up to 100 cigarettes, right? So you can see that we're using information from this SMQ020 and SMQ040 to create that definition for current smoking. So let's see how that happens, how that plays out on chi-square's platform. So here, we have selected our two variables, and we want to create a composite variable. This is the first variable. Let's expand this. This is the first variable, SMQ020. This is the second one, SMQ040. So SMQ020 says, if you have smoked up to 100, if you answered 1 here, so let's compare. For those of you who will be looking at the manual, let's show you how it aligns side by side. Where is it again? Oh, sorry, it was from a back arrow. Okay, all right. So for those of you who want to be comparing it side by side, so here, replace current smokers to 0 if SMQ equals 2, right? So SMQ equals 2 means if you're never smoker. So here, what we're going to simply do is SMQ equals 20 equals 2. We're going to drag it to, let's make sure we just double shot. So if SMQ020 equals 2, that's never smokers. All right, so we're going to move this here and just drag it there and call this never smokers. So when you're creating a composite variable, this is where you put the newly created variables here. And this is the original parent variables. So here, it was simply saying, oh, if they've said 2 to here, then that means they're never smokers. So we'll just drag them from here to there. Then the next one says, if SMQ020 is 1 and SMQ040 is 3, then they're former smokers. All you have to do is say, if this is 1 and this is 3, so we're going to move this one and drop it here. And when you drop it, it's going to ask you, what's the relationship? Is it and or is it or? Well, it's and. So we're going to select and. And that creates that group, which we're going to just move here. Right? And that group is, what's the name for that group? It's former smokers. So we're going to call this former smokers. Edit label and call it former smokers. And then the remaining one says, replace current smoker equals 2 if SMQ equals 1 and SMQ40 is either 1 or 2, right? So SMQ40 is either 1 or 2. So this and this and that's it. We'll drag it there. And that's how we create it. So it's pretty straightforward. If we do not want to, let me edit the label and then I'll show you another way of doing it. So this is never, former, and current. Current smokers. And yeah, this will give you exactly 100% of the time the exact same thing as though if you had written your code manually, right? But again, it's a just more visual way for, for people who just do not like to suffer, right? It just makes it easier to do so. And then that's how we create the variable. You can proceed to conflict resolution. Conflict resolution is just a way for the platform to automatically check if you've made any mistakes. And the variable name is current smoke. So again, the platform will just verify to see that, okay, did you make any mistakes? If you made any mistakes, it's going to flag them. If you did not make any mistakes, it's going to tell you you're all set. So that's how we create variables. So tomorrow we're going to stop here for today's session. Tomorrow we will then see we have already set our analysis to weighted mode. We're going to see how then can we generate estimates and write something like this MMWR, wherever it is. Yes, like this. How do we now generate tables like this and and write up the paper? That's what we're going to focus on tomorrow. So I'm going to stop here and see if you have any questions and answer them accordingly.
Please feel free to raise your hands if you have questions and you'd like to ask verbally. We will share the attendance link right now. Please check the chat box. Remember to provide your full name and email address if you would like to receive a certificate of participation. Okay. Any hands? Questions? Feel free to post them. Okay, Chikari. You can unmute.
Okay. Thank you very much. I would like to say I am a statistician myself, but the way how the facilitator was presenting actually gave me a challenge to say I think I still have a lot to learn. That was awesome presentation, and I learned a lot from the presenter. So I'm not sure if is reachable and accessible for any mentoring in terms of data analytics for our PhD programs that we are currently pursuing. Because we thought we understand data analytics because I did advanced data analytics, but the way how the facilitator was presenting and explaining, and I have learned that I was actually doing it wrongly altogether. And I think I would need to learn more from the facilitator. So if it's very accessible and reachable for Europe, I think he would need to work with him hand in glove so that we learn a lot from him. Thank you. Over.
Well, thank you very much for your kind remarks. So we have sessions like this, and we're thinking of also opening up avenues for other sessions where like we could have write-a-thons, which are simply just a fancy way of saying that a whole bunch of people could come together and write their papers together in one large environment. You can even bring your bottle of wine wherever you are and be sipping. Hopefully you don't get drunk and start putting bugs into your code. Right. But on a more serious note, right, have sessions where people can work together. And if you have questions, you can ask them. So we're trying to think of how we can open up more of those avenues and also just get people more empowered. For example, with just using the platform, right? A lot of work has been put into the analysis suggester to just make sure that even if you're not very proficient in a particular aspect, you can't go wrong with the analysis wizard. It will always guide you properly. But we're going to announce future sessions that we have. So just make sure you follow us on our LinkedIn so you can be kept abreast of those announcements. Thank you. Next question, please.
So how accessible are you, sir? I don't think you answered.
Is that not what I answered now? I said I will provide the sessions that is that a trick question? Yeah, we'll provide announcement of sessions where we'll be having that people can come. in general, I am very accessible at those sessions.
Thank you. Next question is, my question is about descriptive survey design. How will I derive my samples from the population? Why is convenient sampling techniques is not satisfied for selecting lecturers for participants in a research study?
Okay, so the reason why convenient sample is not appropriate in that context, now just be very clear, we're not saying that convenient sample is bad. We're saying that convenient sampling is bad if you are interested in this cycle of inference, where we draw a sample from a population, and from that sample, we make inferences to the population. Now, this is the problematic part. This arrow here, let me see whether we can change the color of this arrow. Oh, I can, right? But bottom line, this arrow here, this is where the problem comes in. Convenient sample allows you to fetch this sample from its population. Fine, there's nothing wrong with this arrow. But if your intention was to make inferences from the sample back to the population, that's what we'll now have to start fighting, because you cannot make that kind of that jump, right? So if you just wanted to stop here, I will draw a sample and I'll make an inference from this sample back to this sample, then there's no problem. So as far as you're just speaking for the sample and you're not trying to, make inferences from that sample to the population, then well, there's no problem. There's no fight at all. So it's not bad. There's no such thing as this is bad sampling or this is good sampling. The question that matters is, what is your intention? That's the only thing that matters. If your intention was to make, generalizable, inferences from the sample to the population, then the mathematical basis for inference is randomness. Without randomness, then you have no mathematical basis for making those kind of generalizations, and that will not work. If, however, your intention was to just limit your conversation to this, I am only speaking to my sample, I'm not speaking to the population, then you're fine. You can use whatever sampling techniques you want. So I hope that's clear. Now, to the other part of the question, how do you draw a representative sample? Well, one, first of all, it's a two-part question. The first question is how many? The second question is how. So the questions of how and how many are important. How many tells you the sample size you need, right? So you can simply go to the chi-square platform under data collection and go to sample size and select the kind of study you're interested in. In this case, I assume you're interested in a cross-sectional survey. You provide the parameters like the level of confidence, the prevalence of the outcome, the population size. If cluster sampling will be performed, in this case, most likely no. Once you provide the parameters, you click on Get Results, and the platform will give you the total number of people that are required based on the parameters you've selected. You can also look at the formula used in the calculation. Now, that solves the first question of how many. The second question is how. How then do I sample these people? That takes you to the sampling tool. And with the sampling tool, there are two ways to do that. You can either draw a representative sample for a country using the sampling frame that we have created. So for example, if it's your survey is from the United States, you can select the country and say, well, I wish to reach X number of clusters. We use the second administrative units in each country as clusters, which are counties or county equivalents. Let's say I wish to get to 30 clusters and my total sample size is, 1,265, whatever that number was. And I click on Get Sample. The platform will then apply a two-stage PPS sampling technique, which is a probabilistic sampling approach. And you tell me that, okay, well, hey, if you're interested in getting a representative survey of the US, these are the places which you should sample from, right? And so I can use that information and sample accordingly. It's the same table here. Or I can say, well, I want to upload my own sampling frame, which is my own spreadsheet with all the lists, and sample with either simple random sampling or systematic sampling or cluster sampling with two-stage PPS. And I can also do that, right? So that's a two-part question you always have to answer. How many people do I need for the study? And how do I sample them? The answer always calls back to what is your intention? If your intention is to generalize, then you must use a probability-based sampling technique. If you don't care about generalizing, then you can do whatever you want. Whether it's convenience or judgmental, it does not really matter.
Thank you, Prof. And just a note for those who are joining for the first time, please note that the session has ended. Basically, once Prof is done presenting, you can just complete the attendance register and you are free to leave. We only end the sessions once all the questions are answered. All right, so here's another question. How are the PSU and strata determined in a data set that you want to apply weighting?
They are determined at the time of study design. So whoever designed the study sat down and said, here is what, oh, by the way, we're going to do it. It's a course on survey design and data collection in a few weeks from now. So if you really want to learn how those things are created at the design stage, because somebody has to sit down and design them, right? So if you want to become an expert in that, you really want to make sure you attend those courses. But at the design stage, based on the design stage, we implemented the survey, and that's what distills down into your data set at the end of the day. For you who is just picking a data set to analyze, all you need to do is make sure that you have read the documentation to know that what is the stratum variable. The variable always sounds like strat something, strata, stratum, so you can't miss it. The PSU variable will always sound like PSU. It will always have some PSU in the name, so you can't miss it. The weight variable too also always have some variation of weight in it, weight, WGT, or something like that. But please don't assume, right? Always read the documentation carefully to make sure that you're on the right step. All right, next question.
My question is not on this topic, but the previous session. For descriptive data analysis, can we have prevalence proportion instead of just prevalence for a point estimate?
Prevalence can be a proportion or a percentage. So a percentage. So yeah, you can choose to express it however you want, right? So you can choose to express, and just so we're all clear, let me make sure we're all 100% clear of what we're saying here. So let me insert a text box. This is a proportion. This is a percentage, right? So this is prevalence. So prevalence, you can say, I'm going to express my prevalence as a proportion or as a percentage. It doesn't really matter, right? You can say, oh, the proportion of smokers was 0.5. The percentage of smokers was 50%. But in general, for clear communication, always use percentages, right? It's just clearer. If you say 0.5, there's some guy out there who will think you're saying 0.5%. And you will add a percentage sign to it, even though you meant 0.5 as a proportion. So to avoid all of this ambiguity, it's generally better to just make sure you're on the same page with everybody and just say 50% instead of saying 0.5 as a proportion. But it's your prerogative at the end of the day. You can say it however you want, and you'll be accurate. You'll be accurate, at least from a technical perspective. But from a communication perspective, just have pity on your readers, on your listeners, and just say 50%.
Thank you. Is access to enhanced data restricted to only US citizens, or everyone can access and publish from the dataset?
Everyone.
Okay, I'm a student intern wondering if Chi-Squares Inc. offers some virtual internships.
Yeah, we'll announce it.
Okay, well,
if we're offering it.
all right, so we have Oluyemisi. Please unmute and ask your question. Okay, please unmute.
Okay, thank you so much, Prof. I'm a student of Utah State University, a PhD student. And currently I'm working on the NHANES data sets for my dissertation. And I really appreciate your step-by-step on how you explain how we can work with that. But currently I'm having issues with the weighted variables, because some of the variables, some of the data set that I joined together at this weighted variables. So at first I was struggling with it, like because the same weighted variables were replicated in some of the data sets. And right now I'm currently analyzing some of my research questions. However, I'm really struggling with how I can infuse that weighted weights into my analysis in R. But with the chi-square platform, I don't know if I should move to chi-square platform to continue with the analysis.
That's a question that only you can answer. Generally, it's less on tools, because we never do research for the sake of tools. We do research for the sake of results and impact. So at the end of the day, it's like whichever is more whichever is easier for you. I mean, chi-square was built for people who have, like I said, for an 8-year-old child, right? That they should be able to generate insights. So the idea that you have to struggle with code, because what happens then is people spend a lot of time trying to fight with code and debugging and like, geez, how do I fix this error? How do I? So if you want to avoid all of those issues, then maybe the chi-square platform might be appropriate for you, right? But if you prefer, just write. There's also some people who they believe that the only way to write a paper is to write code, and that you have to suffer. If you are a disciple of that school of thought, then maybe you want to stick to R. So I don't know. Day, my point is that it's completely up to you. But you can definitely try the chi-square platform and see how how easier your life might be. But again, it's you have to try and see that, because that decision ultimately is yours.
Okay. Thank you so much, sir.
You're welcome. Yeah.
Thank you. Napo? You may unmute yourself. Napo? Okay. Let me read in the meantime. This is regarding weights, actually.
Hi.
If you're out,
Sorry.
yeah.
Oh, my humble apologies. I think technology is showing me flames this side. Thanks, Prof. and Dr. Lungile. It's been a while since our last meeting. I really appreciate it as usual. Prof, apologies if I might have missed the train somewhere, because despite me living right across the street from a national key point, we still have load shedding here. So it sort of interfered. It took away about 20 to 25 minutes of the session away from me. I thought I could explain that. Yesterday, I tried to replicate, I think it's the same exercise that we do today and others that we did previously, and I downloaded, because I'm in management sciences, so I downloaded some data sets from Kaggle and other platforms, and I tried to practice all by myself, but I hit a snag where I struggled to make sense of some of the values in the spreadsheets. They are sort of written in Greek. So I couldn't really make sense of it. So how do I make sense of all of those values? I don't know whether it's in the process of recoding or renaming them. I would appreciate if you can assist me across that hurdle.
So just to be clear, which just to be clear, what spreadsheet?
It's an Excel spreadsheet.
Excel spreadsheet.
It's a data set based on Excel spreadsheet.
Okay, maybe if you can just take a screenshot of that and drop it in one of our community groups, then
Okay.
Then yeah, but I'll definitely provide some feedback on that.
Yes, because the CSV and the XLSX, something like that. Yeah.
Okay.
Okay.
All right. Yeah, let's do that. We'll just take a screenshot of that Greek-looking column or columns, and we'll translate them into simple English.
Okay, Prof. But it won't be within the next 24 hours.
That's fine. Take
tomorrow,
your time.
most
No
definitely.
worries at all. Yes.
All right. All right. Thank you.
You're welcome. Yeah.
Thank you. All right, so I'll continue with the question. This is regarding weights, actually. If your outcome comes from the examination data, but was collected only for specific age groups and not for everyone who underwent the examination, should we still use the examination weights in that case?
So that's exactly what we're doing with the case study. The outcome of interest in our case study is periodontal disease, which is done. So NHANES, remember that NHANES is across the lifespan, and they obviously you need to have teeth. Obviously, you need. Sorry, a dental joke just popped into my mind. Okay, sorry, stay on topic. All right, so the perio assessment was done only among those who were aged 30 years or older, right? So you can see that it's a subset of all eligible individuals in NHANES. So you have to be 30 years or older to have participated in an NHANES examination. But here, look, we're merging together three data sets. Demographic, which contains information for everybody from age 0 to the maximum age 80 or whatever. And then we're combining with smoking, which, if I remember correctly, is from age 12. I may be wrong. And then the perio file, which is only persons age 30 years or older. In this case, our outcome is perio. So that's the most important data set that matters, right? So even if the demographic file had 10,000 individuals in it, only 3,000, maybe 3,600 of those may be eligible for analysis. So when the chi-square platform is linking your data sets, those merges, is accounting for those things, right? Individuals, even if there were 10,000 of them, only individuals who have information for the perio file will be eligible for the analysis, right? And the weight you must use cannot come from the weight for interview, because the perio, which is our outcome of interest, periodontal disease, was done in medical examination context. So the weight we should use here should be for the smallest people. Remember the umbrella we talked about? You want to go into the umbrella with the fewest people, remember? So in this case, we will have to use the medical examination weight, because you have medical examination weights on one hand, and then you have interview weights on the other hand from 10,000 people. But the weight for medical examination were only for 3,000 people. So that means that we have to go into that umbrella with fewer people, meaning we have to use the medical weight, not the interview weight. So it's your job to essentially find out how many people, compared to to the other weights available, right? If based on the outcome. So if the outcome, for example, is here's a kicker, right? If I am analyzing data among the individuals who have 30 years or older, and I'm using periodontal status as a covariate in my analysis, but my outcome is self-reported smoking, and that outcome came from interview weights. I won't use the medical examination weights just because I have a covariate. Remember that the kicker here is that we are focusing on the outcome. So the outcome is what drives the bus, right? The dog should always wag the tail. And in this case, the dog is the outcome, which will always determine the weight we have to use. So keep in mind, we are always referring to the outcome. And when the outcome is concerned, always go to the umbrella with the fewest number of people. All right, next question.
Thanks, Prof. This is a follow-up to a question you've already answered. Just a caveat to your explanation, Prof. Are you saying a proportion of 1.24 should be reported as point estimate of 124%, while the confidence interval from 1.12 to 2.24 should be 112 to 224?
Sorry, can you say that again a bit slower? Or let's just repeat it slower. I'm getting old. I can't hear very well.
Just a caveat to your explanation, Prof. Are you saying a proportion of 1.24 should be reported as a point estimate of 124%, while the confidence interval from 1.12 to 2.24 should be, in brackets, 112 to 224. Close bracket.
So proportions, as a rule, can only lie between 0 and 1. So it is impossible mathematically for you to have a proportion of 1.24. It can't happen, right? Because proportions are bound by between 0 and 1. So this is not possible. So you can't have this. So we can't talk about how to interpret it, because it can happen, because it can lie only between 0 and 1. Percentages lie between 0 and 100. So here we have proportions 0 and 1, and here we have, am I still showing my screen, Lungile?
Yes, we can see your screen, sir.
Then percentages lie between 0 and 100, right? So if you have 1.24, perhaps it's a percentage, not a proportion.
All right. So thank you. It seems that's all we have.
All right, awesome. Thanks,
No
everyone.
more questions. Thank you very much, Prof.
All
It was a
righty.
great session. And yeah, thanks everyone for joining and staying. Oh, Charles, you're still alive. Oh, I thought you raised your hand. Okay.
That's
I guess you were just showing me that you're around. Okay. Oh, here he is. Sure, Charles, you can unmute yourself and say something.
Thank you, Prof. I've missed a lot. I've been on transit all this while. In fact, my question is not actually on this section, but it's something that is a bit worrying to me. I don't know when you can fix that session around sampling size and sampling determination. With what we've taught us and what we've learned, like we've always said, it's hard for people to unlearn what they think they know before to get a new knowledge. So talking to some people around here, their understanding around sampling size and sampling size determination is far from the reality of things we've learned from you. So I don't know when you can fix that section, then I can drag some few persons, and maybe when they hear from you, perhaps they will understand that I was not just saying it, that I have it from a good authority. Over.
Oh, thank you. Well, I think that people do things a different way may not necessarily make it wrong, right? People have their own ways of doing things. But so the bottom line is this, right? The two things could be equally true. I'm not sure exactly how the approach to use, but I think one way we can approach issues of sample size is that it's not they're all approximations, right? So in as much as whatever they're doing is plausible, well, you can't, it's not a conversion mission. We're not necessarily here to convert the world to
Yeah, so Prof,
yeah.
maybe let me be more direct so you understand what I'm saying.
Okay.
I use this your analogy of, for example, when you're cooking food for community, the way you test the food, you see the same way you test it when you're cooking your own personal food, which is just a straightforward analogy that anybody can, can decode. So now, so many persons around my circle, when you talk about sampling size, for example, at least you understand Nigeria, somebody is working in Nasarawa for a particular target group, let's say pregnant women. Now, when you are saying sampling, and when I even say sample for the target group, if you know that target group population, you can now do your manipulation around that. But they will not tell you, no, that what you are going to use, if you bring a sample, let's say I bring a sample size from chi-square platform and say this is my sample size and this is the calculation and this is what was done. Now they will say it's too small compared to the population of Nasarawa. And I will tell them the population of Nasarawa generally will not affect that sampling size, unless we are talking about the target population, which will be far, far lesser. Like people that are pregnant, that will be pregnant, or pregnant women, or women of reproductive age in Nasarawa, is far, far lesser than the entire population of Nasarawa. So maybe that's the context,
Okay.
the discussion happened. Over.
All right, thanks. So we're going to share the dates. We're having a session on study design and data collection, which will be down, I think, a few weeks from now. So we'll have the announcement, and so you're free to please share that with them. Thank you for that. All right, Lungile, do we have any other questions?
No.
All right, awesome. Well,
No.
Thanks everyone. We look forward to seeing you tomorrow for the second part of the session. Have a great day.
Thank you, Prof. Thanks, everyone.
Bye, everyone.
Have a good.
Bye, Prof.
Thank you, Prof.
Cheers, bye.
Bye.
Lungile, I've missed you. How you doing?
Bye.
Ben, what's up?
Yeah, I'm available.
It's been a while though. You abandoned your brother now.
Oh,
Is it they abandoned
you
us?
abandoned
We have
us.
been around.
Exactly.
Network has been my problem. I will register to attend. I will not be able to.
That's why you are attacking first, so that we will not attack you.
That is very accurate, Ben.
I will just do this thing, and I'll plan that by the time the session will start, I will be at home for where I will just be hanging. The network will just sky. So painful.
What you do is, if you are planning to be at home 1 hour before the time, now plan to be at home 3 hours before the time.
Honestly, sometimes now when you're in the field now, you would have planned how your day will go. You understand that kind of
that is how it goes now. Try to compel yourself to be at home 3 hours before the time. Cut off every other thing 3 hours to the time. Yes, that's how to
the challenge is usually, if you are in the field alone, it's easy. But when you are in the field with the ministry people now, you know how it works there now.
Yeah,
you understand?
That's true. That's true.
You can't work with your own energy. They will just be dragging, and you cannot also leave them in the field. That kind of stuff.
Yes, that's true. Just keep trying your best. You're still trying. You're still doing well. No problem. Yeah. Well done.
Well done. How is your stuff going now?
Yeah, we are doing well. We're progressing.
Okay, that's fine.
Yeah, thanks so much.
I've collected my ethical approval, so I've collected permission. Yes. So hopefully, I'm just waiting for funds now to go to deploy my app.
Wow, that is great.
If you open that app now, it's different from what you used to know.
Wow. That is lovely. That is lovely. That's good.
Mm.
Yeah,
So,
you're really breaking through now.
so how will I do now?
Very soon you are the one that will be organizing tutorials for us.
It's well known.
I swear.
Well done.
Well done, thank you.
Yeah.
Yeah. Dr. Longile is still recording. You can stop now.
Is he still there?
She's there.
I thought they stopped the recording.
Yes, I'm still here. Okay, I thought my
The recording
colleagues
is
stopped. Maybe.
No, it's still there.
Thank you very much.
You're
yeah.
welcome.
Thank you.
Thank you.
What happened to your video? We're not used to just seeing your name. This is very unusual.
Very, very okay. I'll try to put it on now.
Okay.
Yes. Aha. Yeah, you go.
That is the bell we know.
That's what we know. Same background, exactly. Good
Since
to see
everybody
you.
is in the shadow, I have to be uniform to be in the shadow. Let it not be as if I'm the one now lecturing.
No. You don't look like someone who wants to do what everyone else is doing. You don't seem like the conforming type.
Okay, that's good.
So yes, this is good. You must stand out.
Okay, thank you so much. Thank you.
Thanks.
All right.
I actually see Elia's message. He was asking me to stop to end the recording and the live stream. Okay. He got kicked out. Okay. But thank you. You helped us.
Yeah. Thank you. Dr. Longile, I want to say something.
I'm afraid of what you're going to say.
No need to be afraid. It's just on the presentation of Prof. The screen is really not big enough for some of us to see what's happening. And he already knows it, and he knows his screen, he knows his slides. But some of us that don't know it, we are new to it. So it's quite small for us to pick anything much. So some of us are relying more on the audio